Hello. This week's JavaScript project is called Factoid, and it allows you to interrogate a simple knowledge base that you create. In fact, this week there are two programs. Firstly, a simple interface to let you set up the knowledge base fairly easily, and then a program that will take simple queries and search for the answers in that knowledge base. I'm not really going to talk very much about the initial interface program, as it doesn't really count as artificial intelligence. What you're looking at is the screen view in a browser, Firefox in this case. In fact, the screen is so long that I've had to put the bottom half on the right. The screen shows a knowledge base corresponding to the semantic net that I showed you in the lecture video, with a few extra items and facts added. You remember the one about birds and mammals being animals and Henry being a sparrow and Gertrude being an ostrich. Yep, that one. In fact, along with both the JavaScript programs, I included this sample knowledge base on my website for you to download if you don't fancy creating one for yourself. Link below as usual. Firstly, you enter the objects, the nodes in the semantic net, in the top text area, one on each line. Click on the button Load Objects to put these into memory. The program will come back with a message saying how many objects it has taken on board. Enter the types of relationships present in the knowledge base. Not the actual relationships between any given pair of objects, but only the types that exist. If you look at the semantic net from the previous video, you will find that it may do with only 5 types of relationship. Meaning is an example of, can, eats, has, and is. Because the relationship is such an important one, and I can't think of any knowledge base that wouldn't need it, the program automatically gives you that one. You can change it, of course. Relationships can be transitive, meaning they can apply in chains between one object and the next. For instance, is transitive, meaning that if mouse is a mammal, and mammal is an animal, then it follows that mouse is an animal. We can trace from mouse along the is-a link to mammal, and from the mammal node along another is-a link to animal. And it's just as good as going from mouse directly along one is-a link to animal in one step. Relationships can also be reflexive, meaning that they can apply both ways round. I can't think of many of these, but one example is married to. If Fred is married to Bertha, then it automatically follows that Bertha is married to Fred. Similarly, another one could be synonym of, so that specifying that fast is a synonym of quick automatically means that quick is a synonym of fast. Once all the different types of relationships have been entered, click on the Load Relationships button underneath. Once you have loaded in the objects and the different types of relationship, you can use them to build a semantic net. At this point, a trio of drop-down select boxes appears, 2 for objects, separated by 1 for a relationship. After that, there is a checkbox to indicate that the relationship is a negative one, i.e. not true. For instance, if you wanted to say that birds can fly, select bird from the first drop-down list, can from the middle one, and fly from the third one. To say that ostriches can't fly, select ostrich from the first list, can from the second, and fly from the third, but put a tick in the box to indicate that can is actually can't. Every time you enter a link on the semantic net like this, click on the Accept button at the end to load it into the system, and a new set of drop-down lists will appear underneath it. The final step is to click on the button All Done. This turns the data that you have entered into a format that the second JavaScript program can read, and display it in the final text area. It also selects it, so that all you need to do is copy it into the clipboard and paste it into some text editor for saving. Of course, you don't have to use this setup program to create a knowledge base. It's just a text file with data in it in the format that you see here, listed in columns on the screen because it's typically quite a long file. Here's the sample knowledge base. It starts with the number 17 to indicate there are 17 objects in the knowledge base, each listed on a separate line. This is followed by the number 5 to indicate that there are 5 types of relationship, and the name of each relationship is followed by a 1 on a separate line to indicate that it is transitive, or a 0 to indicate that it isn't. We don't store whether a relationship is reflexive at this point. Finally, we have the semantic data referring to these lists of objects and relationships. There are 22 relationships stored in the semantic net, each defined in terms of 4 numbers. The number of the object at the tail of the arrow, the relationship, the number of the object at the point of the arrow, and a 0 or 1, indicating positive or negative relationship. Ignore the comments. The setup program adds them simply for readability. For instance, the 4th line of this section reads 9080, separated by commas. Object number 9 in the list of objects is Wiggles, Remember, the counting starts at 0, and object number 8 is the one before it, i.e. worm. Relationship 0 is the first one in the list, which defaults to is a, and the 0 at the end means that the relationship is a positive one, i.e. Wiggles is a worm, not that Wiggles isn't a worm. Similarly, the last line reads 6, 3, 14, 1. Objects 6 and 14 are bat and feathers respectively. Relationship 3 is has, and the 1 at the end indicates a negative relationship, so the line means that the bat does not have feathers. If a relationship is reflexive, then 2 lines are added to the text area at this point, one for each direction of the relationship. Going back to the example of Fred being married to Bertha, if Fred and Bertha are objects 112 and 207 in the knowledge base, and married to is relationship 50, then lines 112, 50, 207, 0 and 207, 50, 112, 0 are both added. If you specifically wanted to specify that these two weren't married to each other, the last number in both those lines will be a 1 rather than a 0. There's nothing to stop you creating a file like this manually using a text editor, but it's easy to lose track of all these numbers. That's why it's better to use the setup program given, although it is rather primitive. Right, onto the meat and potatoes of the project, the program that interrogates the knowledge base itself. Here's the screen view. You paste in the knowledge base data in the format that you've just seen into the text area and click Load. There are 3 types of questions that this rudimentary system can handle. Firstly, it allows you to ask whether a particular statement is true or not, such as bat is warm-blooded. Select the parts of the statement from the first set of the drop-down lists. There is also a drop-down box that lets you select not if the relationship in question is something like bat is not warm-blooded. Then click on the first Ask button to ask the question. Below that, you can get all the objects that form the first part of a relationship with a given object. For example, if you want to find out all the objects that eat worms, select Eats from the relationship list and Worm from the Objects box, and click on the second Ask button. The last type of question lets you retrieve some of the properties for any given object, i.e. find out all the things that Henry could do, or all the things that Mickey eats. This time you specify the first object and the relationship, together with the word not if you want it, before clicking on the third Ask button. The program consists of 212 lines of JavaScript code, and, as usual, I start off by listing the global variables. You can see the arrays for holding the objects and relationship types, with the variables num objects and num relationships, holding the numbers of each for convenience. The array transitive holds whether each of the relationship types are transitive or not. The array semantic holds the number of actual relationships in the semantic net. The variables line and lines are used to read in the data and are made global so that they can be used by more than one function. After that, values are defined for yes, no, and don't know, simply for convenience. The first relationship type in the list, index number 0, is a, and it is special because it allows any object in the semantic net to inherit all the properties of others. For instance, if Fred is a police officer, then all the things which are characteristic of police officers are also characteristic of Fred, unless Fred has exceptions to any of them. You might recognize function getLine from last week's JavaScript program. It is used to extract single lines from the array lines, while ignoring blank lines and lines that start with 2 slashes, indicating a comment. Essentially, it means get the next valid line from that array. GetLine is used in the function loadStuff, which loads the data from the initial text area. The text is retrieved and split up into separate lines in the array lines. Then line is set to 0 to start reading from the first line. Firstly, the number of objects is read, followed by all the objects themselves into the appropriate array. Then the number of relationship types, followed by the types themselves, although this time they come with a flag indicating whether those relationships are transitive, 1, or not, 0. Finally, the semantic net data is read in. In this case, we're only interested in the 4 numbers at the start of each line, separated by commas. So we read in the line and split it up using a space as the word separator. We only want the stuff that comes before the first space, so the only element of the array that results that we look at is the first one, index 0. The rest are irrelevant to us, comments or whatever. The actual data for each of the arrows in the semantic net are then extracted from this first word, as it were, by separating it using commas as the delineator. The last part of the function loadStuff sets up the drop-down lists for the questions. This can only be done after we have the data to put in those lists, so the lists only appear on screen at this point. The function selectObject, for example, creates a drop-down list for all the objects in the knowledge base, and there's a similar function to create a drop-down list for the relationships and a very short one to include the word not or miss it out. Each list is given a unique number as a parameter, so the first question, for example, refers to lists numbered 0, 1, 2, and 3. As the lists are constructed, they are written into division tags already present on the web page. Each question is followed by an ask button to actually ask the question. This is the code for function ask1, which tests whether a specified relationship is true. The two objects, relationship between them, and the negation, i.e. not, are read from the appropriate lists, numbers 0 to 3, as set up before, into subj, rel, obj, and neg. Then the function testRelation is called to determine whether this relationship is actually true or not. The answer comes back in the form of a number, 0 for no, 1 for yes, and 2 for don't know, which is translated into English and displayed on the screen. The second button, instead of producing a yes, no, don't know answer, produces a list of items that have a certain relationship with another object. It is done in a similar way, except instead of reading the first object in from the web page, it tries every single object in the knowledge base in turn to see if the answer is yes for any of them. If so, they are added to a string variable s, which is then displayed at the end. If s stubbornly stays at the empty string, then no object matches the condition, and the program displays a "nothing as far as I know" message. A similar function applies to the third button, except that this time it is the second object which is allowed to vary, and is tested for every object in the knowledge base. Function testRelation firstly detects if there is a direct relationship between the two objects, i.e. not at a distance, but the correct arrow linking the objects directly in the right direction. In the example on screen, this would return yes for the relationship cheetah is quick or feline is a mammal, but it would return don't know for cheetah is fast or feline has fur or hair. However, the power of the program lies in being able to spot relationships at a distance. It should return yes for cheetah is fast or feline has fur or hair, and this is done by two further functions. The first detects transitive relations, i.e. if the relation is transitive, such as is, then it should trace down the chain of is links and return yes in this case. Please note the extra part of that condition underlined. This is a function that is only called if the relationship is transitive. For instance, human eats fish is a relationship, and so is fish eats plankton, but it doesn't follow that human eats plankton. Eats is not a transitive relationship, and this function wouldn't be called for eats. The second detects is-er relationships. Since cheetah is an example of a feline, it inherits all the characteristics of that type of animal. Feline, in turn, inherits all the characteristics of mammal. So if mammal has fur or hair, then so does feline, and so does cheetah. The easiest of these three tests is the direct test. A variable ans is set to don't know as the default value for the answer to the question, and then a loop checks through all the relationships in the knowledge base. If a relationship is found that matches the one being tested in every regard, then ans is set to yes or no, depending on whether it's a negative relationship or not, i.e. ostrich cannot fly, rather than ostrich can fly. The variable temp is made a copy of the appropriate line in the array semantic, simply for convenience. Testing is-er relationships is a little harder. Here's the first part of the function, which draws up a list of all the objects of which subj is an example. There might be several, or even many items in this list. In the examples we've seen so far, objects have only ever been examples of one other object, but there's no reason why an object can't be an example of two different things. Fred could be an example of police officer and golfer, both of whom might have very different characteristics. Note that the negative parameter for the direct test function is 0, as we are interested in determining which objects this item is an example of, rather than isn't an example of. If the number of items in that list is 0, then the item in question isn't an example of any other thing. There is no is-er link extending from this item, so the answer to the original question is don't know. Alternatively, all the items in the list have to be tested. If the question can be answered for any of them, i.e. the answer isn't "don't know" for that item, then the question has been answered. The function knows that this is the case as it loops round for all the items in the list, and we set that number of items to -1,000 to indicate "don't bother" anymore. The other possibility is that items taken off the list and tried don't answer the question. In that case, we check to see if they are examples of something else, in which case that item or items are added to the list for testing. As long as that list contains at least one item, then there is at least one avenue to be explored. The function terminates when the list of items to try no longer has any items in it, or the question has been answered, of course. The functions to test for transitive relationships is almost identical to that for testing is-a relationships, except slightly simpler. This is because when we trace our way along the chain, we just need to check the items we find itself, and not the characteristics of those items. Here's the first part of the function, and as you can see, it is identical to the previous function. It produces a list of all the items with the same relationship and the same starting point. Again, if this list has no items in it, then the answer to the question is "don't know." On the other hand, each item in the list is taken off and tested directly for the relationship. If the answer is found to be yes or no, rather than "don't know," then the answer is found, and the number of items in the list is artificially set to -1,000 again, to indicate that the search is over. Otherwise, the next link in the chain is searched for and added to the list if such a link exists. It might be instructive to compare the structure of functions test transitive relation and test is-a relation to see how they are similar and how they differ. There, that code was really rather hairy, although it was probably just those last two functions that took some head scratching to get your minds round. Clearly the program is very primitive as it stands, and you might like to implement some extra functionality. At the moment, it can't answer questions like how many items match a particular relationship. A more sophisticated program might be able to infer some extra rules from the data entered. For instance, if you told it that sparrows have feathers, can fly and are warm-blooded, and that parrots have feathers, can fly and are warm-blooded, then it would be reasonable to ask whether both sparrows and parrots are part of some supergroup, birds in this case, all of which have feathers, can fly and are warm-blooded. The simple example we have here includes one special type of relationship, namely is-a, which is treated slightly differently from the others. You might like to promote other relationships to special status, such as synonym of. At the moment, if we say that cheetah is quick, and that quick is synonym of fast, then the program has no way of noting that cheetahs are fast. An improvement to the program would treat nodes in the semantic net identically if they were joined by a synonym of relationship. It would also be fascinating to learn whether anyone out there managed to use this system to implement a serious knowledge base, i.e. not some toy system like the one we've used as the example here, something that encapsulated real knowledge in some technical field that provides some useful function. If anyone out there does manage to construct such a system which others find useful, I would dearly love to hear about it in the comments. Also, please don't forget to click on the like button and subscribe to the channel if you haven't already done so.